Good morning or good afternoon, everybody. My name is Elisa Baum, and I am Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to just conduct a bit of house cleaning. If you wouldn't mind, could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you can hear me. And let's see here. Yep, I see some hands. Okay, great. Thank you very much, everybody. Next, during this webinar, you will be on mute. Should you have any questions at all during the discussion, please enter them in the questions field within the control panel, and at the end of the webinar, we'll take time to answer as many questions as possible. Those that we don't address will be addressed in a follow-up blog post on Percona's MySQL performance blog. In addition, I'll make sure that everybody here gets a recording of the webinar and the slides within the next 48 hours. With that said, I'd like to thank you for attending today's webinar, New Replication Features in MySQL 5.6, and this is presented today by Percona's consultant, Stéphane Combondon. And with that said, I'd like to turn the floor over to Stéphane. Stéphane, go ahead.
Thank you, Elisa. So, hello everybody. My name is Stéphane Combondon, and I'm a consultant at Percona. And today we'll see some of the new replication features in MySQL 5.6. So, first, of course, a very quick introduction for those of you who don't know replication very well. And then we'll see four main topics: so binlock checksums, crash-safe replication, multi-threaded slaves, and finally global transaction Ids. So let's start with a quick introduction. Why do you want to use replication with MySQL? Well, there are many different reasons why you want to use replication. One of the most popular is the ability to scale out the reads. So if you have an application that perform lots of reads, it's usually quite easy to offload at least some of the reads to the slaves. So that's a very efficient way to build a large application. Replication can also be used for high availability purposes. Different goals. You can also make sure that it's easier to recover, etc., etc. You can also have one copy of your data, for instance, in the US, and another copy in Europe. So the possibilities are endless. Slaves can also be useful for backups. So a slave per se is not a backup, but you can, for instance, take a backup on a slave instead of taking the backup on the master, which may be interesting because backup has often some impact on the machine. So on a slave, that can be more efficient. And you can also use replication for testing new versions of MySQL or for grading. You can start by grading a slave first, and then if everything looks well, you can upgrade the master. And you can also imagine many more scenarios where replication can be useful. So now, how does replication work with MySQL? It's quite easy, but it's interesting to know. So we have a master and we have at least one slave. So this is the easiest case. One master, one slave. We have writes that are run on the master, and the master will record every write on a log, which is called the binary log. So you have the list of transactions there. Then the slave has the first thread, which is the IO thread. And the IO thread, the master, and requests the contents of the binary log. And this IO thread will create a local copy of the binary log events or the transactions inside the binary log, and this copy is called the relay log. And then on the slave you have a second thread, the SQL thread, which will read the contents of the relay log and then replay the transactions in the relay log. So this is how it works. And a few things that you have to know is that replication is asynchronous. So it means that you should plan, if you want, for instance, to run some reads on the slaves, you should plan that slaves may not be up to date. So you may read stale data, and your application may be aware of that. And here we have seen the picture for one master, one slave. If you have several slaves, each slave will have its own relay log. So the mechanism of the IO thread requesting the contents of the binary log will be duplicated for each slave. So each slave is really independent from the others. Okay. So first feature that is new in MySQL 5.6, binlog checksums. So what is the problem, or what was the problem with replication, is that the master and the slaves can have different data. And even when replication runs without any error. For some of you maybe, but there are many reasons why replication can go off rails. So, for instance, you may have non-deterministic queries. So these are queries that can give different results when executed on the same data set. So executed the first time on the master, one result. Executed the second time on a slave, the same data set, different results. So of course, the master and slave will now have different data. A common mistake is to write on the slave outside of replication, which is of course very bad. But if there's no real way to prevent that in MySQL. So you can set the read-only flag on the replicas, but that does not prevent the users with the super privilege. So it doesn't always work. Another reason why replication can, why master and slaves can have different data is the wrong usage of replication filters. So specifically with statement-based replication, replication filters can be very dangerous. You can also have problems using non-transactional storage engine like MyISAM. It can be like you're starting a transaction, and in this transaction you're using a table, you're using a MyISAM table, and then you're rolling back the transaction. So the transaction won't be transmitted to the slave, of course, as it has been rolled back, but the change to the MyISAM table won't be rolled back. So there will be a difference between the master and the slave. Another reason is that you can have corruption in the binary log or in the relay log, and you can imagine many more scenarios where master and slave will have different data. How can you check that? Well, before 5.6, it was quite difficult because the server provided nothing. So your best option was to use Untitled Checksum from Percona toolkit, which can So how does it look like? Here we're checksumming only one database. So you have the -d Sakila option, which means that we are checking differences between master and slave only on this database. And then you have the output, and what we can see is that we have a difference. So in the diffs column we have 1, which means that we have a difference, and this is in the Sakila.payment table. So this tool can help you identify where master and slave have different data. So This is the first step, because of course here you know that in this table you have problems, but you don't know where exactly. So after that you'll have some extra work to be able to precisely locate the row or the rows where you have problems. But anyway, it's a tool that allows you to detect some discrepancies, such discrepancies. So now let's get back to MySQL 5.6, how to use checksums on slaves. The first step is to enable checksums on the master, because of course you will compare the checksums computed on the master with the checksums computed on the slave. So step 1 is to enable checksum on the master with the binlock checksum option. By default, it's already on and set to CRC32, which is the only algorithm available at this point. And then the second step is to enable the checks on the slaves with the slave SQL verified checksum set to on. Again, it's enabled by default. So what happens now when there is a problem? Well, let's say that you have relay log corruption. Then you will run show slave status, and the good thing is that you will see in the last error field that you have an error. The thing that is a bit disappointing is that the error message is not very clear. At least it's very verbose. So it says, okay, you have an error, but it can be because the master's binary log is corrupted, the relay log is corrupted. This may be a net problem, etc., etc. So this is not very specific. A bit better, you can use MySQL binlog. So MySQL binlog -- verify binlog checksum, and then you pass the relay log to MySQL binlog, and then you have an error, which is, in my opinion, much better, which says even CRC check failed. So most likely this is an even corruption. Okay, we have a relay log corruption. So that's good. How can you enable checksums on the master? So the goal of the checksums on the master is to be able to detect binary log corruptions. In this case, you will set master verified checksum equals on. This is good, but for me the disappointing thing is that even when this setting is set to on, it won't prevent you from writing to a corrupted binary log file. So, okay, if you test the binlog file manually with, for instance, show binlog events, MySQL will say, you have an error, you have a problem. Okay, so this is good, but unfortunately, it doesn't prevent you from writing to this corrupted. To recap, what are the limitations of this feature? If we refer to the previous list, the list of what can go wrong with replication, we had a list of things, and well, the checksums that I presented only help in one scenario. It only helps when you have binary log or relay log corruption. So it doesn't help, for instance, if you have a non-deterministic query. It doesn't help if you use the replication filters in a wrong way, etc., etc. So this is good, but this is not a feature that will make replication safe. Another limitation is that it has a CPU overhead, because of course you're doing more work, you're computing checksums. And another limitation is that it's mainly useful to detect relay log corruption, but in the previous versions of MySQL, relay log corruption is usually, not automatically, but it is usually easily detected because it usually triggers a replication error. Okay, so it says, relay log corruption, and before you had error, simply. But, well, this is a limitation in my opinion. Okay, next topic, crash save slaves. So, what is the problem there? When you have replication, of course, the slaves have to store some information about which transactions have been executed, and this information is stored in two files by default, relylog.info and master.info. And the problem is that these files are updated after the transaction is committed. So let's get a diagram. So we have transaction here, it's committed, and then a few moments after replication information is updated, then you have another transaction which is committed, and then replication information is again updated. So what can happen? Let's say you have a crash. First scenario, you have a crash here. Well, that's not really a problem because replication information is in sync with the latest transaction that has been committed. So, well, let's say no problem. What happens now if you have a crash here? Well, that can be a problem because you have a transaction that has been committed, but the slave has not stored the fact that the transaction has been committed. So when you restart replication, there is a risk, for instance, that you will re-execute this transaction, which may cause a duplicate key error. So how can we make slaves crash safe? Well, an ID, and this is the ID in MySQL 5.6, is to mention a part of the transaction. So now, instead of having transaction which commits and then the replication information update, you encapsulate the replication information update inside the transaction. So this is how it will look like. Now, what happens if you have a crash right there? Well, this is no longer a problem because that means that the whole transaction will be rolled back. So there will be no inconsistency between the state of the data and the replication information. So this is how it works. Now, how do you enable that? You will need to change three settings. So you will table how to store relay log information, IO thread information. So that's the first two settings, and you will also need to so to do that, you will need to restart MySQL. So it's not needed for the first two ones where you only need to run stop slave, but you will need to restart MySQL for the third one. Of relay log recovery. Updated at each transaction. So it means that even if you're using tables to store it, is not a this will make sure For instance, regular spinning disk, you can use SSDs on DB flush transaction commit. You can
Welcome to GoToWebinar, Webinars Made Easy.
executed all the transactions. Okay, so this is what is indicated in show slave status. You can tune how often a checkpoint is done with the slave checkpoint period setting. And if you have a crash or if you stop replication, when you restart replication, all the transactions that need to be executed since the latest checkpoint will be executed first. So this is good for recovery. What are the limitations of this feature? The first one is that we need to partition your data across several databases. So if you have all your data in a single database, well, this won't help you. If you have 10 databases, but let's say one database holds 90% of the write traffic, this won't help you very much. So this is really interesting when you have several databases and when the write traffic is balanced between these databases. It will not help you if you have cross-database transactions. So for instance, if you have DB1, DB2, but if you have a transaction using both DB1 and DB2, well, the implementation to say if it's safe or not to run threads in parallel. So it won't do it. It won't try. If you have a lot of databases, so for instance 100, 500, you're very likely to hit bottlenecks. So at the moment I'm not aware of this because the only scenarios I've seen were with n, which is quite small, so n equals 3, n equals 5, things like that. But if you have n equals 100, and if you're able to have lots of execution in parallel, you will probably hit CPU bottlenecks or disks bottlenecks or over bottlenecks. This is something that we still have to find and to see how we can find workarounds. And another limitation is that the output of show slave status should be taken with care. So if you're familiar with replication, you probably know that the first thing you have to do when you want to diagnose something with replication is to look at the output of show slave status. Well, here it's a bit more complicated. You have show slave status, but you have the slave worker info table, which has important information as well. So you should look at both to have a good picture of what is going on. Okay, let's now talk about global transaction IDs. What is the problem there? So a common thing that you have to do with replication is to reconfigure replication. So for instance, you have one master, 10 slaves, the master crashes, okay, so you will promote one of the slave, let's say slave number 1 to be the new master, but the problem is that slave number 2 to slave number 10 are not slaves of the new master. So you have to reconfigure replication on every other slave to inform them that they have a new master. And this is not easy because if you have the same event on slave 1 and on slave 2, it's very, very likely that they will have different position in the binary log. So if you have an event with position, let's say 100 on the master, on the old master, well, on slave 1, it may be position 200 and then in a different binary log file. So reconfiguring replication, that can be done, but that may be hard, and this is very tedious and error prone. And specifically when you have a crash, you want to do things as quickly as possible, and this is when you have the most opportunities to make mistakes. So let's look at a picture. Here we have a master, slave 1 and slave 2, and we have slave 3, which is a slave of slave number 2. And let's say that we have the same event, which on the master is on the binary log file number 3 and at position 10,290. Well, on slave number 1, if the binary log is enabled, you will have another binary log file, another position. On slave 2, again, another file, another position. And in the relay log of slave number 3, again, another position. So same event, but different offsets, different positions everywhere. So now let's say that you want to reconfigure replication on slave 3 and make it a slave of, let's say, slave number 1. What should you do? Well, the first thing is to look at the last executed transaction on this server. So you can find it on the relay log, and you can also find very easily the corresponding position of this event on the master of slave 3, which is slave 2. But as we saw, on slave 1, you will have another position. So what should you do? Well, you should have a look at manually look at the binary log files of slave 1 and look for the transaction, the last transaction executed on slave 3. And when you find it, well, you can find the right binary log file and the right binary log position, and then you can reconfigure replication. But this is not very easy. For instance, if you have lots of identical transactions that are executed, it may be difficult to be 100% sure that you have identified the right transaction. So reconfiguring replication, okay, that's possible, but that's not easy. So now let's look at global transaction IDs. First, what is a global transaction ID? it's simply a unique identifier of a transaction, and it's unique across all servers in a replication topology. A GTID has two parts. The first part is a source ID, so it's the ID of the server, of the server, and the second part is the transaction ID. So, for instance, when you have executed a sequence of GTIDs, you will have something like what you can see on the at the bottom. So the source ID 3E11 etc. colon and then 1.5, meaning that you have executed transactions 1 to 5. So now let's have a diagram of the same replication topology, but using global transaction IDs. So this time, if we look at one specific event on the master and on slave 1 and on slave 2 and on slave 3, they will have exactly the same identifier. So if you want to reconfigure replication on slave 3 and say, okay, now I want slave 3 to be a slave of slave 1, that's very easy because you already know the right position. So the only thing that you have to do is to say, okay, let's change master host and maybe the user and the password, and that's all. You have nothing to do to calculate a position, etc. So that's very, very convenient. Okay, good. How can you enable GTID-based replication? So let's say that you have a running system, so you're using replication with standard replication, so without GTID. The first thing you have to do is to stop the writes on the master. So for instance, with set global read-only equals 1, and make sure all the slaves are in sync. So for that, you can compare the output of show slave status with the output of show master status on the master. If it's the same, well, the slave is in sync. When it's done, you can change the configuration for all the servers. So what should you add? You should add binary logging for all the servers. You should add log slave updates and GTID mod equals on and enforce GTID consistency, which is, I'm not sure if it's mandatory, but at least it's strongly recommended. When you're done with that, you can restart all the servers and then instruct them to use GTIDs, well, at least instruct all slaves. And this is simply done with the change master command. So change master to master to position equals 1. So you can see here that with GTIDs, you don't need to bother with positioning. You don't need to specify a global transaction ID. You only set auto position, and the replication will itself take care of the right position. And when it's done, you can disable read-only mode, and you're done. What are the limitations of global transaction IDs? Well, probably the most important one is that, as we've seen one or two slides before, is that you will need to shut down all the servers at the same time. So it means downtime, and of course this is bad. So the main limitation is that it's not possible to have a mix of let's say traditional replication and GTID-based replication. So you will not be able, for instance, to move slave number 1 to GTIDs, then move slave number 2, then slave number 3, and when it's done, promote one of the slaves to be the new master. That won't work. So it's all or nothing, and that, yeah, that may be a bad thing depending on your application. Another limitation is that binary logging should be enabled on all the slaves. This is necessary in the current implementation, And of course, on slaves, this can have a significant impact on performance. So, well, it depends, of course. But you should be aware that this is needed. You have a few limitations on the statements that you can use. So, for instance, it's not possible to use temporary tables inside transactions with global transaction IDs. But anyway, temporary tables with replication usually don't play very well. So it's anyway better to avoid temporary tables. And another significant limitation of GTIDs is if you want to use crash-safe slaves or if you want to use multi-threaded replication, well, the support for GTIDs is not very clear. So you have new monitoring tables. So for instance, for multi-threaded replication, you have a slave worker info table. But if you look at the fields, you have no field for a GTID. So how can you diagnose, how can you repair a crash if you're using both GTIDs and multi-threaded replication? This is not clear, and this is one of the main limitations. Okay, of course there are many other features regarding replication in MySQL 5.6, and I won't have the time to tell you all the details about them, but let's have a quick look. So one of the very interesting features is the binary log group commit, which is a feature that has been broken for, I don't remember, but nearly 10 years, so since MySQL 5.0. So it's now fixed. If I remember correctly, it's disabled by default for backward compatibility, but it's probably good to enable it. You have an optimized row-based replication, which can be, for instance, interesting if you have text fields, blob fields. You have the MySQL utilities, which are a set of command line tools which are very useful with replication and GTIDs. So, for instance, with GTIDs, we have seen that it's very easy to reconfigure replication. So you can imagine that it should be easier to automate failover, for instance. Well, this is something that can be done with the MySQL utilities. You have tools like MySQL failover, which are built exactly for that. So if you're planning to use GTIDs, it would be a very good idea to look at the MySQL utilities. You have time-delayed replication. This can be very useful. So for instance, someone drops a table, a very important table. If you have a time-delayed slave, you have some time to be able to dump this table and to recover it without needing to recover from a backup, for instance. So before MySQL 5.6, you could do that, but with an external tool such as PT slave delay from Percona toolkit. But now it's built in, which is much better. And you can also you have new options in the MySQL binlog utility that allow you to backup binlogs remotely, and that can be very interesting for instance, to mirror the binlogs in real time. So replication in MySQL 5.6 has improved a lot, and this is a really good thing. I'm almost done, so this will be the time for question and answer. And if you have any question on replication or other MySQL topics, feel free to drop me an email. And just a reminder, in a few weeks we have a conference that looks very promising in London. So it's November 11th and November 12th. And you have the URL of the website. So I'll be there, and if any of you will be there too, I'd be very happy to discuss with you. So I hope to see you there. So, okay, so now this is time for question. Back to you, Alisa.
Hi, thank you so much. Okay, there's quite a few questions. We'll take as many as we can. And like Stefan said, those that we don't get to, we'll do a follow-up blog post on MySQL Performance blog. Okay, first question, Stefan. If I run on Amazon's RDS, do I need to worry about enabling crash-safe slaves, or is it that already in place?
So this is a very good question. Actually, I'm not sure of the answer. So I don't use RDS very often, and I'm not sure how it's configured on with new instances using MySQL 5.6. So this is probably something that I should check and address in a future blog post.
Okay, next question. How the relay log purge will manage in case of multiple DB replication running on multiple threads?
Well, in this case, each thread is responsible for executing some of the queries in the relay log, and all the work is coordinated by the SQL thread. So if you want to have information on what is going on, you should look at the new monitoring table that I mentioned, which is located in the MySQL system database, and which is slave worker info. And in the different, you have different fields, and among the fields you will find the fields, some of the fields you are used to have with show slave status. So for instance, we have a relay log file, relay log position, and the corresponding bin log file and bin log position in on the master. So that will help you monitor and understand what happens there.
Okay, the next question. What is the maximum database's slave configuration with optimal performance?
Well, this is a very good question, but of course it's not possible to have one-size-fits-all answer for that. So, for instance, let's talk about multi-threaded replication. This looks good because if you look at some of the benchmarks, you will see that replication throughput can be improved 5 times, 10 times. So this looks very interesting and promising. The problem is that it's really application dependent. So as I mentioned, if you have 10 databases and if only one is responsible for 90% of the write traffic, you will not benefit from this feature. And for the other features, well, it's the same. So for instance, crash safe slave. It's interesting because it has been a pain for many people to have slaves that are inconsistent when they experience a crash. So they spent lots of time trying to fix the inconsistencies and so on. So with this feature, well, this is done automatically. This is good. But imagine that this doesn't happen to you, or imagine that it happens once every year. Is it worth it? Well, that's not sure. Same for binary log checksums. This can be good to detect some kind of corruptions, but, well, it has an overhead. So the right answer to the question will be you have different options. So you have flexibility. You can enable or disable different parts, and you should benchmark, or you should first imagine which parts are important or significant for you and which are not, and then you should benchmark with and without these parts to see if performance improves, if data safety improves, or if there's no change. But, well, telling you that you should use, for instance, free parallel workers and disable global transaction IDs? Well, no, it's not possible because it really depends on the application.
Okay, the next question is how does the relay log purge will manage in case of multiple database replication running on multiple threads?
Well, I think it's the we already answered that question. It was like question number 2, right?
Sorry about that. Yep, okay. So the next question is, let's see here. How can be higher bin log on slave 1 when master file is lower position-based replication? Hope that made sense.
Oh, yeah, okay, I see. This can happen. For instance, each time you restart the server, a new binary log file will be created. So let's say that you have 2 servers, the master and the slave, and let's say that you have binary logging enabled on both. Okay, so when you write on the master, you will start by writing on the binary log file number 1, and when the changes are recorded on the slave, they will be recorded on binary log file number 1. Now let's say that you restart the slave. When it restarts, it will automatically create a new binary log file. So now the master may still be writing on binary log file number 1, but then the slave will be writing on binary file number 2. So this is why it's really difficult to manage positions with standard positioning. It's because when you have a position on one server, it doesn't mean that another server on the same replication topology will be behind or ahead. You never know.
Okay. The next question is server ID and server UUID. What is the difference? And then there's a second part to that. Do we need both simultaneously?
Yeah, that's a good question. So server ID has been there for a very long time. So this is what you needed to have to turn on replication. So a server ID, a unique server ID for each server, and now you also have a server UUID, and this is an identifier of the server, but it's not used for replication. So the server ID is the unique identifier for the server. Okay, so and it's something that I think it's new in MySQL 5.6 and didn't exist in MySQL 5.5.
Okay, next question. Is it possible to use Ttid if there are functions and procedures on master that create, delete new partitions on master and are replicated to slave?
I think so. There are some limitations on the kind of, let's say, the kind of statements that you can run with Ttid's, but the limitations are quite light. So I mentioned temporary tables, for instance, and I know there are a few things about create table select. I don't remember exactly why. But for this specific case, I don't think this should be a problem. So of course, you should test it because, well, there may be a bug. It can happen, but there should be no problem.
Okay. What is the difference between syn binlog equals 10 and binlog group commit?
Okay. The syn binlog option means that each time you write to the binary log, you will flush the write to the disk. So you make sure that the write is persistent. By default, you have sync log equals 0, which means that each time you write to the binary log, you you don't make sure that the write is persistent. You let the operating system flush this write for you, and usually this will happen once every second, which means that, well, if you have a crash, you may have some writes that will be lost in the bin log. So this is the purpose of the sync bin log. Are you okay with losing a few transactions if you have a crash, or do you want every transaction to be persistent? Now, binary log, the group commit is that beginning with MySQL 5.0, writes to the binary logs are serialized. So there will be only one transaction at a time that can write on the binary log. With the group commit function feature, several transactions can be written at the same time on the binary log. But of course, having binary log group commit does not prevent you, if you want to have everything persistent, to set sync bin log equals 0. I'd say, to say that in another way, sync bin log is about data safety, and group commit is about performance. So of course, sync bin log has an impact on performance, because if you want to make sure that everything is persistent, this has a cost. But the main goal of this setting is the data persistence. And the main goal of the group commit is the performance.
Okay. The gentleman who asked the question about has a follow-up statement, and this was about UUID and GTID replication. He says, server UUID is used to GTID replication. It is part of each GTID. My question was that if the server UUIS is globally unique, why do we need another unique server ID? You probably
Okay. Yeah, okay. I didn't understand the initial question correctly. Okay, and well, the answer is I'm not sure. So I won't try to tell you something because I'm not sure. So maybe this is something that I should address in a blog post. So I need to have a few more checks to be able to answer that question.
Okay. We have time for just a couple more questions. All right. So if crash-safe replication is my utmost requirement, can I still use GTID replication and/or multi-threaded replication?
Oh, this is a very good question. So yes, you can, but you should probably test it very well. So specifically, if you want to use crash-safe replication and GTIDs, you should try, for instance, to break replication and see how you can fix it. Because, well, first with GTIDs, a few things that you may be familiar with are no longer valid. So, for instance, it's not possible to skip transactions with slave SQL sleeve counter equals something. You have to inject an empty transaction, so it may look weird in the beginning. And the second thing is that when you're using a crash-safe replication, you have two new tables. I don't remember the name, relay log info repository and master info repository or something like that. And in these tables, you won't find any reference to a GTID. So the only position that you will find there is the binary log file and the binary log position. So if you have a crash and if you want to make sure that you have GTID number 100, for instance, well, this is not easy with this table. So the answer is yes, you can use crash safe slave and GTIDs, but make sure to test correctly to be able to fix replication in case of errors.
Okay, and the last question of today, and there are several more, which, by the way, Stefan will address in a follow-up blog post, is what will happen if GTID is used in a transaction that creates a temporary table is run on the master?
Oh, this is a good question. So you should check the manual for that. So it's very clearly stated. And I don't remember if you will have a replication error or if the master will not accept the write. I'm not sure of that. So again, I can do that in the blog post, but you can very easily find that on in the manual on the pages talking about GTID replication.
Okay, well, that ends today's webinar. I hope that everybody enjoyed. Stefan, thank you so much for your time today, as well as everybody else who has joined us. Have a wonderful evening, morning, afternoon, depending on where you're listening from. And I hope to see you again on our next webinar, which is the first week in November. And everyone have a wonderful day, evening, or morning. Stefan, thank you again.
Thank you, everyone.